Thank you for joining us for the Air Conditioner Markets and Policy Opportunities webinar. CLASP organized today's webinar as a means of presenting the results of 4 air conditioner market studies conducted over the last year. In addition to the CLASP team members who will be speaking today, we are also joined by some of our partners. We're joined by Loli De Jesus from Energy Solutions in the Philippines. She will be helping to present on the Philippines today. We are also joined by our colleague Caitlin Vandenberg from the World Bank, and she will be discussing the World Bank's technology transfer projects for low GWP refrigerant technologies for ACs. And last but not least, we are joined by Jessica Brown, the director of the Kigali Cooling Efficiency Program. Both CLASP's projects that we're presenting today, as well as the World Bank's projects, are conducted under the K-CEP program. So Jessica will be providing an introduction today. Following the presentations from all of our panelists, we will hold a question and answer session. To try to stay on time, we will just have one Q&A session at the end of all presentations. If you have a question in the meantime while we are speaking, please feel free to send it to us using the Q&A function of the webinar tool. You'll see it at the bottom of your screen. With that, I would like to welcome Jessica Brown, Director of the Kigali Cooling Efficiency Program, to provide some opening remarks about the K-CEP program and our mutual goals. Jessica?
Thank you very much, and hello everyone. I am Jessica Brown, Director of the Kigali Cooling Efficiency Program, and thanks so much for inviting K-CEP to speak. I wanted to just very quickly give a bit of background about K-CEP for those of you who don't already know us. The Kigali Cooling Efficiency Program was launched in April 2017, and we are a $51 million philanthropic collaborative set out to respond to the growing greenhouse gas emissions from the cooling sector. So cooling, and here I'm referring mainly to cooling appliances such as air conditioners and refrigerators, are a major contributor to climate change, and emissions from cooling are really on the rise. So if we just look at air conditioners, today there are about 1.6 billion air conditioners in use, and that number is projected to go up to 5.6 billion by 2050. In terms of the greenhouse gas impacts associated with this, well, it's really linked to 2 main causes. One is the refrigerants that are used in the cooling equipment. So that's the HFCs, or the longer term is hydrofluorocarbons, which are a very potent greenhouse gas, as many of you are aware. And the other reason is because these appliances are highly energy intensive and incredibly inefficient for the most part. So K-CEP is working really in tandem with the Kigali Amendment of the Montreal Protocol, which is the amendment working to phase down the HFCs used in cooling around the world. And we're doing this by helping developing countries transition to improve the efficiency of the cooling equipment at the same time as they're phasing down those HFCs. So our work on the energy efficiency of cooling is meant to double the climate benefits that we can get out of the Kigali Amendment alone. As a grantee of K-CEP, CLASP is supporting a variety of activities to help raise efficiency standards and improve testing efforts, providing training, other types of really important capacity building activities, and to help implement national market transformation initiatives. And CLASP's work on market assessments and policy options in particular is absolutely critical to setting a strong technical foundation for new policies, particularly the minimum energy performance standards that we're focused on, which are so critical for improving efficiency of cooling appliances. And CLASP, I will note, has already achieved some really great policy success in the countries in which it's operating. I'm thinking of Kenya in particular. I'm sure we'll hear more about it in this webinar. And I just want to thank CLASP again for its great work on behalf of K-CEP and all of our funders. Thanks much, and over to you.
Thank you, Jessica, for that introduction. I would now like to introduce CLASP's Policy and Analysis Senior Manager, Ana Maria Carreño, who will provide an introduction to the 4 CLASP reports and a brief overview of our methodology for conducting market assessments and policy impacts analysis. Ana.
Thank you, Rebecca, and thank you, Jessica, for the kind word the kind words. So yes, today we are going to be hearing about the work CLASP is doing under the Kigali Cooling Efficiency Program, specifically to improve efficiency of cooling equipment by raising efficiency levels in standards and labeling programs, as well as other market transformation activities. And part of this work is providing policymakers in the various countries where we are working with a comprehensive review of their cooling markets so that they can evaluate what are the opportunities and the impacts of increasing efficiency, and ultimately use this evidence to support inform policy decision making. Just as part of the methodology in general, we're working with partners on the ground, which we are going to be hearing today from, to conduct extensive data collection. We interview all relevant stakeholders in the cooling sector, from manufacturers to importers to government officials as well. And I think another important piece is that we also conduct visits to retailer stores so that we can gather very detailed information on those models that are available for sale for consumers. With this information, as we will be hearing today, we were able to develop a comprehensive characterization of the market, from market size to technology types to what are the current efficiency levels to prices. And we modeled the impacts from various policy scenarios with the goal to quantify what are the benefits of increasing minimum energy performance standards or raising or revising labeling categories. So you will be hearing from our team findings on 4 of these market assessments in 2 particularly very different regions. We're going to be hearing from Kenya, which is a small import country that recently implemented energy efficiency policy for the first time. So we already notice some differences in the Kenyan market, not only on the size, but also on the energy efficiency levels, which are very low compared to other markets that we are evaluating. And this is mostly due to the absence of energy efficiency policy that promotes higher efficiency products. And this is a common issue not only in Kenya, but in other African countries that are still not regulated, let's say. We expect that there's going to be growth in the coming years. So it's really an important opportunity to start setting policy right so that you can spark that market transformation to high efficiency products. And then on the other hand, we're going to be seeing the review of the cooling markets in Southeast Asia, in particular Thailand, Vietnam, and the Philippines. These markets have been regulated for many years. There's presence of local manufacturing, which poses some important challenges for regulators, as you will see. But there are also important opportunities to increase efficiency, and especially to get large energy and greenhouse gas emission savings. Among these markets in Southeast Asia, you will also see that there are major variations, not only from efficiency. For instance, we will hear from the Philippines that it's a little bit lagging behind other countries due to some challenges in the local context. But we will also see how the difference in applying regulations, and I'm talking specifically about technology neutral approach that sets requirements for all technologies, inverter and fixed speeds the same way, or non-technology neutral approach that requires different specifications for this equipment, causes variations in the market. So we'll be hearing from Vietnam that has very successfully implemented a technology neutral approach that increased the popularity of inverter air conditioners. And we will be hearing in Thailand as well the very successful voluntary labeling program, where now the most popular class is the most efficient class, but there are many opportunities still to tap into higher efficiencies and move the markets to higher efficiencies. So with that, let's dive and hear from our colleagues.
Great. Thank you for that introduction, Anna. Now that Anna has set the stage for understanding these 4 market assessments, we will dive right in. So first, we will start with Kenya, and I'm happy to introduce CLASP's Naomi Wagura to take you through the findings for Kenya. Naomi?
Thanks, Rebecca. Thanks, Anna, and thanks, Jessica. So yeah, we're going to go through our findings from our market assessment and policy analysis from the data collection that we did in 2018, last year. So next slide, please. So the Kenyan market is a purely import market, as Anna said, and the imports vary between 24,000 and 43,000 per year. So it's a very small market, but expected to grow, of course. And so this is data for the past 4 years, and this is import data from the customs body here in Kenya. Next slide. Okay, so we looked at where the AC is coming from, where they imported from, and also validated that data from the appliances themselves on where they're manufactured. So as you can see on the left there, for the first 5 years, most of the units have been coming from China, but there are also some units that are coming from other countries, especially Thailand. In 2015, there were quite a number that came from the UAE. Which is a popular route for importation of products into the country. And on the right, you can see the country of manufacture. So in 2018, so this is from the product data, from the products that we actually saw in the market in 2018. So 55% were manufactured in China, 13% from Thailand, 12% from Malaysia. So a lot of the units are coming from Asian countries. Next slide, please. So diving into the product's characteristics. So on the types, the single split ACs make up most of the market, 87% of the market. So that's what you see on your left there, and some multi-split units, but not that many, and some portable ACs and some window ACs. And then on the right there, you can see that the most common units are below 36,000 BTUs per hour. Next slide, please. So looking at the refrigerants and the compressor types, so as Jessica mentioned in her introductory remarks, this is key in phasing out not just inefficient air conditioners, but also air conditioners that use harmful refrigerants. So you can see in the Kenyan market, there's 69% use R410A, which is a HFC, which still has high global warming potential, but more alarmingly, we still have 27% of the units still having R22, which is a HCFC, which is therefore an ozone depleting substance. So the situation currently in Kenya is that importation of ozone depleting substances like HCFCs is regulated, but only when you're bringing in the refrigerant itself, for example. But the appliances that contain these refrigerants are not regulated. So they give licenses and quotas for importation of the refrigerant, but they don't look at the ACs or fridges coming in or appliances that might contain these refrigerants. And there was a very small portion of ACs that were using R32. And then on the right there, you can see that fixed ACs still make up 64% of the market here. The penetration of inverters is still on the low side at 36%. Next slide, please. So to set the stage for the policy analysis in Kenya, I'm going to take you through how the regulatory framework is set up in the country so that you can understand the coming slides. So we have two main implementing agencies. We have the Kenya Bureau of Standards, which is under the Ministry of Industry, Trade and Cooperatives. So the Bureau of Standards develops, revises and publishes the standards. So they were in charge of developing the standards in 2013, the MEPS document and the test method. And they also manage PVOC implementers. I'll explain what that is in a moment. And they also do some market surveillance to check whether the products that are actually in the market meet the standards that they have set. So the PVOC companies, so PVOC stands for, that has a little error there. So it's pre-export verification of conformity. So that means that because Kenya is mostly an import market, so we need to check for the products that are coming in. So instead of checking them at the port, which will cause a huge backlog, you check them at the country of export. So KEBS has contracted 5 PVOC companies that check products in especially in the main export countries like China, Dubai, and so on. So those are part of the framework because they check for that the products meet the standards in the country. And then on the other hand, you have the Energy Regulatory Commission, which was now renamed actually to the Energy and Petroleum Regulatory Authority, but the roles remain pretty similar to what they were before. So the ERC, or EPRA as they're called now, inspects the test reports for units that are regulated for efficiency, and they issue appliance registration certificates and labels, and they also conduct market surveillance, especially on labeling. and they're under the Ministry of Energy. So next slide, please. Okay, so looking at the current regulations and standards in the Kenyan market, so we had the KS 2463 2013, which was the MEPS document for non-ducted air conditioners. It also contained the test method. So these were published in 2013, and the regulations, the energy appliances, energy performance and labeling regulations were passed in 2016, which made the MEPS for room air conditioners and for other products mandatory. So after the regulations were passed, they gave a grace period of 2 years. So 1 year for products that were coming into the market, and another 1 year for products sold into the market. So products that came into the market from July 2017 had to meet the MEPS, and those that were sold in the market from July 2018 had to meet the MEPS. So in March 2018, CLASP launched the first ever Kenya AC market baseline study, which we're looking at the results today. And once the MEPS became mandatory, especially for retailers, there was a lot of pushback from wholesalers and distributors, basically industry players, because there was a technical problem in the standard. So the testing conditions that were specified in the test method were not well suited to the Kenyan climate. So they required testing to T3 conditions. Well, the Kenyan climate is better suited, and most actually climates in the world are better suited for T1 test conditions. So there was a big complaint that the testing was too expensive, and so they were also unable to meet the MEPS as they were with that test condition. And so there were calls for revision of that standard. Big kudos to the Kenya Bureau of Standards here, because they moved very fast to revise that standard, and CLASP contributed to the revision of that standard. And so in September 2018, the Technical Committee for Room Air Conditioners in Kenya met to revise the MEPS, and by October, they had already published a draft for public comments. Next slide. So the update on that is that we now have a revised RAC MEPS that was published in April 2019, which is great. So going back to the market assessment, so the efficiency levels of RACs in the Kenyan market before MEPS implementation, because our data collection happened just before the MEPS came into effect, we were able to collect some very good baseline data, and the efficiency levels were quite low. So as you can see in that graph there, that all the units had an ER of below 3.4. And with the previous level of 2.8, the previous MEPS levels of 2.8, a lot of the units still did not meet that previous level. So moving to the next slide. So analyzing the impact of what are now the newly adopted MEPS, you can see that the level moved from 2.8 watt per watt to 3.1. So as they were revising the test requirements, they also decided to increase the MEPS levels, because the standard was already pretty old by the time it became mandatory. It was already five or so years old. So they increased that by 11% to 3.1. So you can see that you had a lot of fixed speed room air conditioners that did not meet the previous MEPS, but there were even more that did not meet the revised MEPS. Next slide. So this is just to show the significant market transformation that has happened because of the implementation of the new MEPS. So before, you had 30% of the models that were in the market in 2018 would not have been compliant with the previous MEPS. But with the new MEPS, you have 73% of the models that were available in the market in 2018. And even then, the ones that were in the market in 2018 would only be 1 or 2 star. There would not be any 3-star units. Next slide. Okay, so looking at 2 policy scenarios that we used to show the impact of implementing what were then the proposed MEPS that are now the newly adopted MEPS. And the other scenario was what we called the potential best available technology. So the second scenario involved increasing the current MEPS by 20% to 3.75 watt per watt, with the assumption that since this is a newly regulated market, after the MEPS are implemented, the most efficient units will have that efficiency level, which would be equivalent to 3 stars under the current star rating categories. So just to show the huge difference between what are now the current MEPS, the energy savings from the current MEPS in 2030, and if they increase that by 20% to 3.7 watt per watt. So that's 59 gigawatt hours in 2030 versus 203 gigawatt hours for potential VAT. Next slide, please. Thank you. So this shows the emissions reduction. So this is based on indirect emissions, so emissions from the energy savings, basically. So this is calculated taking into consideration the grid emissions factor for Kenya, and also the energy savings from increasing the MEPS levels. Next slide. So these were the recommendations that we gave based on the evidence that we just presented. So the first one would be to implement the proposed MEPS levels. So this was already done, which is great. So under this scenario, the consumers still get significant life cycle cost savings, and the payback period for the units is less than 3 years. And then you have, at the national level, you have 4% less cumulative energy consumption by 2030, and cumulative avoided emissions of 0.14 metric tons of CO2, as we just saw on the previous slide. And then the second recommendation would be to update the MEPS and labeling schedule every 2 to 3 years, at most 5 years, to continue the market transformation. So taking into consideration that Kenya is an import market, and we're importing units from countries like China, which will probably revise their MEPS in the next few years, and other larger economies. Well, this is a great first step. It's important to continue revising and updating those MEPS every few years. And then the third recommendation would be to conduct a comprehensive consumer awareness campaign that sensitizes the public on the new labeling program for RECs. Because this is a new SNL program, it's important to let the people, basically the public, know that these are the different efficiency levels, and these are the benefits of getting a high efficiency unit as opposed to a low efficiency unit. And this will also help also with market transformation. So yeah, it was pretty informative. It was the first study of its kind, comprehensive study of its kind, and it's going to set a great baseline for future studies to see the impact of MEPS implementation in Kenya. So thank you for listening, and I'll hand it over to Lina, my colleague, who will take us through the Philippines markets.
Okay, thank you, Naomi, for that. Now that we've covered the smallest and youngest AC market of the four, we will move on to the Philippines. Clasps Lina Kelpseta and Loli de Jesus from Energy Solutions will take you through the findings. So I believe Loli will be starting.
Thank you, Rebecca. Hi, everyone. So we are very happy to share with you the result of the market study that was conducted in the Philippines last year. Next slide, please. Okay. As you can see from this chart, the market of AC in the Philippines is really quite small. Since 2012, its growth is just around 5% with a projected 8% annually. Based on the 2017 World Bank study, there are around 800,000 units in the Philippines, and most of these are brand new ACs. Although there is some data showing that there are also importers for second-hand AC, this market is quite small, less than 7,000 units. Next slide, please. In terms of the market distribution per cooling capacity, as you can see from the chart, for the window type AC As you can see, 71% of the surveyed ACs have capacities below 12,000 kilojoules per hour or less than 3.5 kilowatt, of which around 35% were 9,000 kilojoules per hour and below. For the split type ACs, as you can see, around 38% are quite small, below 12,000 kilojoules per hour. This market is consistent with the economic condition in the Philippines, wherein the the buying power of the consumers hinges on, or the market hinges on the buying power of the consumers, because right now the split type aircons are quite expensive compared to the window type aircons. Next slide, please. In terms of market distribution between single, split, and window, again, consistent with the previous slide earlier, the window units dominate the AC market in the Philippines, and most of these have non-inverter compressors. Again, it's due for the fact that the split type aircons are quite expensive compared to the window type ACs. And also, most of the household in the Philippines that are using ACs are quite small, which doesn't really necessitate the need for a split type AC. In terms of, although most of the split type ACs are already using inverter type compressors, because the market for this type of ACs is quite small. It follows that the penetration of the inverter technology in the Philippines right now is currently very slow. In terms of the type of refrigerants, as you can see on the other side of the chart, since the market is dominated by window type ACs, the use of R22 is still dominating the market, particularly for the domestic and imported brands of the ACs. Majority of the split type racks are now using R14A refrigerants. In the Philippines, R22 is considered as part of the ozone depleting substances, and it is currently regulated, and we call this one a chemical control order for ozone depleting substances, in which we have set deadlines for final elimination of this product in the market. Next slide, please. Based on the survey that was conducted in the Philippines, and these were, as Anna mentioned earlier, a survey on the retailers, there are around 48 brands that were identified in the market, but the market is dominated by the local brands, because in the Philippines we have local manufacturers. In fact, the market is dominated by these companies, particularly Concepcion Condura. And as you can see, the brands that this company is carrying are dominating the market, like Carrier, Condura. Another one local manufacturer is Copel, which also holds a huge part of the market. Of this, the domestic assemblers share holds around 40% of the market, and which 30% is shared by Filipino-owned company, which I mentioned earlier, Concepcion, Carrier, and Copel. And as you can also see on the chart, other world brand or global brands are also found in the Philippines, such as LG, GE, Sharp, and Hitachi. And then if you can also see, there are other brands that are uniquely found in the Philippines, such as American Home, Everest, Fuji Denzu, Anbon, and Ariel. But as you can see, in terms of market share, these are quite small compared to the brands which are locally manufactured in the Philippines. Next slide, please. The survey that was done in the Philippines last year, the one that we did, there's really very limited information in terms of the countries of origin for the imported ACs. Of the few that we have surveyed, and of the few that was able to display the country of origin, these were the countries that were highlighted. Okay, and this include China, Thailand, Vietnam, Indonesia, South Korea, and USA. The study team attempted to compare the survey findings to other sources, as you can see on the other side of the presentation, and this data is taken from the UN Commodity Trade Database. And as you can see, more or less the countries that were reflected based on the survey is also reflected based on the UN data, which are China, Thailand, Malaysia, South Korea, and a small percentage from other countries. Next slide, please. Lina?
Thank you. Yes, thank you, Lali. Next, we will look into the prices. Here on this graph, the dots represent the prices for different cooling capacities. The prices here are listed in Philippine pesos. And to note that cooling capacity in the Philippines is measured in kilojoules per hour. In the Philippines in general, fixed speed ACs, which are here light blue colored dots, cost less than inverter units that are shown in green. The majority of domestically produced air conditioners represented here in red are of a smaller capacities, and their prices are comparable to the units that are being imported. The graph also clearly shows that the prices increase with increased capacities, and also, some of the inverter unit prices are comparable to those of fixed speed ACs. Here we have ER graphed for different cooling capacities. The line on this graph represents current MEPS, which are at 2.53 watt per watt for cooling capacities below 12,000 kilojoules per hour, and like Lola mentioned, equal to 3.5 kilowatts. And then the MEPS are at 2.39 for larger capacities. And you can see that all except for the two surveyed units are way above the current MEPS, which means that the market is ready for more stringent policy. Last update of MEPS for air conditioners was done in the Philippines in 2002. And at the moment, Department of Energy is in the process of adapting new MEPS for air conditioners. In regards to label, just wanted to mention, air conditioners in the Philippines are required to bear Department of Energy energy label or yellow label. That is more of an endorsement type, displaying the energy efficiency ratio and other information about the product. However, with the new policy, DOE plans to introduce a label with 1 through 5 star rating. In this project, we analyzed 2 policy scenarios that are shown here. The first one is 2020 ASEAN target MEPS equal to EER of 2.9 is shown as a yellow line in this graph. And then a more ambitious 20% above ASEAN target MEPS with EER of 3.48, which represented with an orange line in this graph. ASEAN target MEPS for air conditioners are the MEPS that the ASEAN member states agreed to harmonize by 2020 under ASEAN Shine initiative, which stands for Standardization Harmonization Initiative for Energy Efficiency. The analysis showed that 2020 ASEAN target MEPS would eliminate about 30% of ACs on the market, but it will not result into market transformation. Because on average, the EERs of ACs on the market are already greater than the ASEAN target MEPS. Therefore, our recommendation is to increase the MEPS to 20% above ASEAN target scenario MEPS to spur market transformation to more efficient appliances and have a greater policy impact. Here you can see that, for more ambitious scenario, the estimated life cycle cost savings are much larger for all three analyzed cooling capacities. The savings vary between 132 and 494 US dollars, with a greater savings for cooling capacity of around 9,500 kilojoules per hour. The analysis also showed that estimated electricity savings and emission reductions in 2030 are significant. Again, under more ambitious scenario, under 20% above the ASEAN target scenario, with estimated energy savings in 2030 of above 2.5 terawatt hours. That is equal to about 10% of total residential energy consumption in 2017. And in terms of emissions reductions in 2030, it's with this policy scenario, the potential for reduction is about 1.8 million tons of CO2 equivalent, which is equal to about 15% of total emissions from air conditioners in 2030, which is, again, quite significant savings. In regards to impacts to local manufacturing, as Loli mentioned, air conditioner market in the Philippines is dominated by fixed speed window units, which is unique in Southeast, unique as Southeast market in Southeast Asia. During the study, we found that, again, like Loli mentioned, that Filipino households favor small size window units that are less expensive, but also they may be less efficient. Two Filipino old companies, Concepcion, Carrier, and Copel, that manufacture mainly fixed-speed window units, have quite a large market shares, and the products are very highly valued by the residential consumers. During our analysis, we estimated that with more ambitious under more ambitious scenario, about 87% of surveyed models that are manufactured domestically would be non-compliant, which it's a very significant impact on local manufacturing. The government of the Philippines aims to reduce the negative impact to local manufacturing, and at the moment is adopting a less stringent MEPS, which are at 2020 ASEAN target level. But as we showed here in a presentation, that more stringent policy approach, in next couple of years, can trigger market transformation to more efficient appliances, can bring more significant savings to consumers, as well as deliver NDC goals. So, yeah, thank you.
Great, thank you for that, Lena. So now that Lena has completed the presentation on the Philippines, I will take everyone through the findings for Vietnam. My name is Rebecca Schloman. I'm also at CLASP. So In Vietnam, we also see a growing market for air conditioners. It's been growing pretty steadily over the last few years. Right now, we estimate the market size around 2.5 million ACs. As you can see on the right, we found a few competing sources of information about this, but for the scenarios that we modeled, we used the estimate from Euromonitor, the market research firm, of 2.4 million ACs. The majority of ACs in the Vietnamese market are split ACs, so our analysis focuses on those. Also, as you can see from the chart on the top right, there is a market for secondhand products in Vietnam at approximately 11%. However, our analysis focuses on the new products. So as I mentioned before, single split ACs clearly dominate the Vietnamese market. However, there are floor standing models, cassette models, and portable models available as well. What you can see in the graph on the right is the penetration of inverter technology. Out of all of the markets we looked at today, Vietnam has the highest penetration of inverter technology. And as Anna Maria mentioned, this is due to their technology neutral approach to minimum energy performance standards. So for inverter ACs and fixed ACs, both have to meet the same minimum energy performance standard that is measured using the Cooling Seasonal Performance Factor, or CSPF. On the right side of that chart, you can see the refrigerants that are on the market right now. And most of the ACs are now using R32 or R410A. We'd like to see a stronger shift towards R32 because R410A is an HFC, but thankfully the proportion of the market that's using R22, that HCFC, is gradually decreasing. And I'd also just like to mention before I move on that this inverter penetration is much higher than it was in 2013. When we looked at the Vietnamese market in 2013, it was only 31%. So that really shows the impact that a switch to a technology neutral minimum energy performance standard can make. On this slide, you can see the popular AC brands in Vietnam. There is quite a diversity of brands available. There's many on the market, but similar to the other markets we've looked at, those large global brands like Daikin, Panasonic, and LG tend to dominate. There are a few local manufacturers of air conditioners, but they don't have as large of market share as those global brands. On this slide here, we can kind of dive into the local manufacturing. Approximately 13 to 15% based on different sources of ACs are manufactured in Vietnam, while the rest are imported. Most of their imports come from Thailand, China, and Malaysia. What you can see in the table on the right are the 6 local manufacturers. And I'd like to just briefly note here that one of those 6 manufacturers, Funiki, has already announced that they will no longer be producing air conditioners going forward. So we'll actually see the percentage of local manufacturing potentially fall. On this slide here, we can see the prices of ACs in Vietnam. And you can see that there is a clear linear relationship between cooling capacity and price. So the smaller the AC, the lower the price in general. The larger the AC, the higher the price. What we can also see is that the fixed speed units are represented by the red dots, and the inverter units are represented by blue dots. You can see that there aren't very many inverter ACs in those higher capacity ranges. It's really just for the smaller, truly residential sized ACs that we have inverter models available. But in those smaller capacities where most models are, those more popular capacities, there are ACs available at comparable prices between inverter and fixed. So in terms of discussing policy revision, we're confident that we can revise the minimum energy performance standards up and help facilitate a transition to more efficient ACs without overly negatively impacting consumers. So Vietnam has mandatory minimum energy performance standards, MEPS, and labels. And based on the retail survey that we did, we were able to see that 99.7% of models on the market in our study bore the certified energy label, which is really great. However, what we also found in looking at the energy labels was that there are the majority of products on the market are actually in the 4 to 5 star range. So Vietnam uses a 1 to 5 star rating scale, and having up to 68% of all ACs on the market in the 4 to 5 star range is not exactly what you want to see in these labeling systems, because it makes it difficult for consumers to differentiate between the models at the higher end of the market. So this is another way of looking at that information. So you can see each of the lines represents one of the star levels, with the gray line at the bottom being the lowest level, or the MEPS. And the MEPS are currently set so that they dip a little bit lower as you increase the size of the AC. And so as you can see, most of the fixed speed units are below the 5 star range, and the majority of inverter units are actually above that 5 star minimum in the 5 star range. So in terms of customers who go into the store and want to pick a high efficiency AC, they might have difficulty choosing if they're looking at an AC at a shelf that only has 5 star ACs, but those ACs can have very different efficiencies. So what all of this tells us is that the Vietnamese market is primed for some policy revisions. So what we recommended in our report is that Vietnam increase the MEPS for split ACs by 20% above the current MEPS. Additionally, we recommend that they revise the energy labeling schedule, those 1 to 5 stars, upwards across every level. This will help to kind of normalize the distribution a bit. And if they wanted, they could consider using a statistical normal distribution to help better distribute models within the market. Additionally, our third recommendation is that Vietnam commit to updating the MEPS and labeling schedule every 2 to 3 years to accelerate market transformation towards highly efficient ACs and just to better help consumers. So what we modeled was that 20% increase to MEPS. What you can see here on this chart is what the current MEPS look like, what we saw in a previous slide, as well as where the MEPS what the market would look like with MEPS set 20% higher. As you can see, the majority of those lower efficiency fixed speed units drop off the market, although some fixed speed units do remain in the market and would still be compliant, and they would probably fall into that 1 to 2 star range. Based on this scenario, 22% of the most inefficient ACs would be eliminated from the market. On this slide here, we look at what would happen if, in addition to that 20% increase to the MEPS, Vietnam increased the minimum level for each star rating by 20% as well. And what you can see is that in addition to increasing the amount of non-compliant ACs, there would be a redistribution of ACs throughout the 1 to 5 star categories. So the amount of ACs in that 4 and 5 star range would decrease, and it would help consumers to better differentiate between those products. So in addition to talking about impacts to the market, we also want to look at impacts to manufacturers. As I mentioned earlier, there are about 6 local manufacturers in Vietnam, one of which, Phoeniqui, which operates under the Hoa Phat brand, is no longer going to be producing ACs in the future. Based on our analysis, we found that 20% of the locally manufactured ACs from our retail study would be non-compliant under a revised policy scenario. However, this is comparable to the impact that foreign brands would face, where 23% of those ACs would be non-compliant. And one of the things we'll be talking about later when Caitlin presents about the World Bank technology transfer projects is that there are opportunities there are opportunities to reduce the burden of these types of policy revisions on manufacturers. And the work that the World Bank is doing could be very complementary to a policy revision. In terms of impacts to consumers, what we see is that there would be a slight increase to the upfront purchase price of those lower end ACs, the ones that sit at the bottom of the market, the least efficient ones. And we estimated that increase to be about 6 to 7%, or equivalent to 17 to 23 US dollars. So this is not a really significant increase to the upfront purchasing price. And as you can see from this chart, the operating costs, and this is based on a 10-year lifespan of an AC, would actually be lower because the efficiency of the AC has increased. And this is really important because energy tariffs in Vietnam are rather low, so it's difficult to achieve benefits for consumers. However, even with this change and with those low energy tariffs, consumers will have a net benefit. Oops. Lastly, I want to talk about the impacts at the national level. A 20% increase to the minimum energy performance standards could result in 2.1 megatons of CO2 savings in 2030 alone. And if Vietnam were to implement this policy in 2020, then we would see up to 9.7 megatons of CO2 saved cumulatively over the 10-year period. This is really great. And as you can see from the gray line, which represents a best available technology scenario where we looked at the best products on the market, there's potential already in the Vietnamese market for up to 65.2 megatons of CO2 savings over 10 years. So these types of policy revisions could have a really great impact on Vietnam. So for the sake of time, I won't take us through all of these key points on this slide, but instead I would like to introduce my colleague, Colin Taylor, who will be taking you through our findings for Thailand.
Hey everybody, I'm Colin and I'll be talking about Thailand. So Thailand is a bit of a different air conditioning market from some of the others we've heard about today. First of all, though not bigger than Vietnam's a bigger market, it's a much more mature market. Where it's not growing as rapidly as some of the other countries, in large part because most people who would want an air conditioner, including most urban residents, already have an air conditioner. And so it's, pretty stable market. The other thing that's interesting and different about Thailand is it's the second largest air conditioner manufacturer in the world, which means that almost 91% of air conditioners available in Thailand are made in Thailand. And Thailand actually produces about 10 million air conditioners a year compared to its domestic consumption of only about 1.4 million air conditioners. So it's also the second largest exporter of air conditioners after China. And that means that the Thai air conditioning industry is a very important industry domestically and has a good deal of influence over the policy process for good reason. It represents a lot of jobs and a lot of enterprises in the country. So the types of air conditioners in Thailand, first of all, there basically are only split units. We didn't observe any portable or window units in the market, but there are a wide variety of types of split units. There are wall-mounted split units, floor-ceiling units. There's a sort of unique type of split unit called a concealed duct unit, where you put the indoor piece in the wall. It's kind of cool. I wouldn't mind having one myself. Thailand is lagging a little bit behind its neighbor in Vietnam in terms of moving to low GWP refrigerants and inverter technology. Inverters only account for a little more than 30% of the market now. However, that's a big increase over where it was 5 years ago when inverters only accounted for 16% of the market. So we are seeing a trend in the right direction for inverter technology. As far as refrigerants, R410A is still the dominant refrigerant, though R32 is coming up pretty quickly. We did see some R22 units still available in the market or appearing to be available. However, we couldn't get price data for these, so these may not be for sale anymore. We would expect that they wouldn't be for sale anymore since Thailand has officially banned the sale of R22 units now. So likely those units aren't actually in the market. Another thing to note is Thailand has a wide variety of brands, again, mostly manufactured in the country, brands that you've seen in other countries like Mitsubishi, Samsung, Daikin, Panasonic, LG. These companies all have pretty significant manufacturing bases in Thailand. Another thing to note is there are some important Thai brands like Saijo Denki, Central Air, Amina Air. And these also are manufacturing primarily in Thailand, though some of the Thai brands also import units from China and brand them with their Thai brands. One thing that's excellent about the Thai market is people really appreciate energy efficiency. The voluntary EGAT number 5 label program is very well recognized, and people use it as an important criteria for purchasing an air conditioner. First of all, consumers consistently say that energy efficiency is the most important factor in selecting an air conditioning unit, and they judge energy efficiency based on this EGAT number 5 label. Something to note about the EGAT number 5 label, it's supposed to be a comparative label that goes from level 1 to 5, with the top level being, and most efficient level being, the number 5. However, it's a voluntary program. So the label levels 1 through 4, manufacturers don't typically ask for those. They only label their units if it achieves the number 5 label. Another thing I'd like to note on this slide is that the second most frequently cited factor in selecting an air conditioner is rapid cooling. And this may be an issue for the penetration rate of inverter air conditioners, because some Thai consumers have expressed the view that inverter air conditioners don't cool as quickly as fixed speed air conditioners. So this preference for rapid cooling may be one of the barriers for inverter air conditioners. So Thailand has MEPS, for mandatory minimum energy performance standards for air conditioners. These are actually expressed in terms of energy efficiency ratio. And so I couldn't put the MEPS level on the same slide because we have the labeling information on seasonal energy efficiency ratio. So what I did here is put the level 1 level for the EGAT number 5 label, which is roughly equivalent to the energy efficiency ratio level. However, if you see a couple of units that are below those level 1s, that doesn't mean they're not compliant with the MEPS. It just means that, you know, it's in that sort of margin for error. A couple things you'll notice here is that the vast majority of air conditioners are out here in the lower levels, the lower capacity levels. And there's a wide range of energy efficiencies on the market. There's some really excellent air conditioners like this one up here with over 27 SEER. Another thing you'll notice is that as the capacities increase, the efficiencies decline pretty rapidly, especially after the policy. The policy doesn't apply to units above about 41,000 BTUs per hour. And it's quite noticeable that once you pass that level right here, the efficiencies drop off immediately and very rapidly. And so despite those higher capacity units making up a much smaller percentage of the market, because they're large capacity and less efficient, they actually consume quite a lot of energy, and there's a good amount of savings potential by expanding policy to those units. As you can see, we've recommended moving the MEPS to about 20% above the inverter level 1 and expanding it out to those higher capacity units where there's a lot of energy savings to be had. Now, the EGAT label number 5 is probably the most important energy efficiency policy in Thailand. As you can see here, most of the units on the market achieve the EGAT number 5 label. One of the sort of perhaps unfortunate things about the label is that it has separate requirements for inverter versus fixed speed units. And probably the reason for that is that many of these fixed speed units that can only achieve the fixed speed label number 5 are made by Thai companies. And so it's important to make sure that, given the importance of this industry for the Thai economy, that these manufacturers are not adversely affected. And so they've kept a lower stringency level for fixed speed units in order to allow these companies to continue competing in the market. However, this has slowed the transition to inverter units and allowed a lot of these less efficient fixed speed units to achieve this label number 5 and appear as if they are as efficient as these amazingly efficient, high efficiency, fantastic inverter units. There's a wide range of efficiencies on here. And frankly, I don't think you can find as highly efficient units as you find in Thailand at the top level in other markets. So one of the other great things about the Thai market is there's really excellent economics for energy efficiency. because there are all of those very high efficiency units for fairly competitive prices, and there's a not extremely high, but higher electricity rates than in some neighboring countries, energy efficiency pays off very well. The best available technologies, even for smaller units, pay off within 4 years, which is shows that it's quite cost effective, especially when you consider that the average lifetime of an air conditioner is about 10 years. So across the board, energy efficiency pays off. And it especially pays off at the higher capacities, where moving from an average efficiency unit to the most efficient unit in the market would pay off in less than 6 months for a 48,000 BTU per hour unit. And so this points to not just a good opportunity for increasing policy stringency, but also for an opportunity to move the market towards those best available technologies on the market, because they would pay off for consumers. So I think there's an opportunity to try to encourage consumers to get there through financing or other market transformation activities. On top of being a very economical proposition, moving to higher energy efficiency has very large climate impacts in Thailand. Per year, in 2030, they could save as much as 8.4 megatons of CO2 equivalent. And moving to the best available technology, which is cost effective, could save 18 megatons of CO2 equivalent. So there's tremendous environmental benefit to be had here as well. So the key things I want you to take away from this presentation is that while the main piece of the market in Thailand is under 20,000 BTUs per hour, those large units that may not have as many sales do contribute significantly to energy use and emissions because they're very large and often inefficient. But they also present a great opportunity for moving to higher efficiency because it's extremely cost effective at those capacities. The second thing is that the differentiated requirements for the label has slowed the transition to inverter units, and in some sense misrepresents the relative efficiency of fixed speed versus inverter units, as most consumers just use the presence of the label as their criteria for picking an air conditioner. And they may, and indeed are, often choosing less efficient fixed speed units over more efficient inverter units. However, it's a bit of a challenge to move to a single set of requirements because it would very adversely affect Thai-owned brands. In fact, only at a 20% increase in Convergence, only 7% of models made by Thai-owned brands would be able to get the EGAT number 5 label, which would really seriously affect their sales, considering how many consumers use that as their criteria for purchasing those. So I think for that, I think we'll hear from the World Bank about the technology transfer program, which may be able to help those Thai-owned brands produce such products, and then allow us to move to a single set of requirements at a higher level for the EGAT number 5. And then the final comment is that revising the MEPS and labeling requirements by 20% over the current inverter levels would save 13 terawatt hours of electricity in 2030 and reduce emissions by 8.4 megatons of CO2. So there's a lot of environmental and energy benefits to be had from the increase in the MEPS and label stringency. And with that, I'll hand it.
Great, thank you for that presentation, Colin. As Colin mentioned, there is a great opportunity for the World Bank's technology transfer programs to aid Thailand as well as Vietnam by helping manufacturers begin to produce these higher efficiency air conditioners. So with that, I would like to welcome Caitlin Vandenberg of the World Bank to give us a brief presentation about the World Bank's technology transfer program. Caitlin?
Thank you so much. Indeed, I will go quickly through it. I think let's go to the next slide because we are running a little bit behind. So I want to quickly go through some of the initial slides that deal with the objective. I think everybody is quite familiar with what the K-CEP objectives are to really increase and accelerate the climate and development benefits of the Montreal Protocol, and then specifically when it comes to the refrigerant transition. But at the same time, also really looking at acceleration in the improvement of energy efficiency of cooling. If we move to the next slide. Yes, then K-CEP focuses primarily on the air conditioning and refrigeration, but obviously there are many other cooling solutions, such as building design, shading, cool roofs, and super efficient fans, and these are still being considered. But at the moment, the energy efficiency cooling management plant are in window number 1, which is focusing on the strengthening of efficiency. Let's move to the next slide. Now, if we look at the status in energy efficiency and the low GWP cooling, it is quite well known that growing energy demand is really driven by rapid economic and demographic growth. At improving the energy efficiency, and it was also mentioned earlier today, really reaps large economic and social benefits. But yeah, what is quite important to consider is the economic development of the local cooling and refrigeration industry, because they have far less capacity than the multinationals. And that's why you see also a large variance in coverage and the stringency in the compliance and the enforcement of the energy efficiency standards for electrical appliances across the region. Now, and then the AC industry has or is really converting manufacturing from the R to a 22 based production. Next slide, please. Now, some of the lessons learned, and they are also quite similar to the earlier presentations that were presented. There is a lot of success of the standards and labeling programs and the policies in the Southeast Asian countries. And this is largely attributed to the ability of the governments to secure the industry buy-in. So eventually both the cost and technology will become limiting factors, and that will also increase the resistance for more ambitious MEPS increases. And I think we are not at that stage yet if you look at these earlier presentations, but really for some of the key recommendations to for every 3 to 5 years to increase the MEPS, these really will become critical factors to take into consideration. Now, if we look at the Thailand AC conversion to R32, then it requires synchronized action on several fronts, and also a critical mass and leadership and coordinated efforts are needed to convince specifically the component suppliers to fill the gaps, because there will be a need to produce R32 compressors in a larger size range. Now, inverter AC is highly competitive, and the technology and the know-how is not so easily accessed by small companies. And this is really where some of the key challenges are, because obviously countries are quite willing to increase the energy efficiency and the standards, but they're not necessarily willing to really kill off the entire domestic industry as a result. And let's go to the next slide. Now, and this is also where the project comes in, and that the objective is really to support the readiness for longer-term transformation of the market towards lower GWP and high energy efficiency refrigeration air conditioning products, both in Thailand and in Vietnam. Now, this will be done by a few key components. One is to create an enabling environment for the supply and the demand of these high energy efficient RRCs with lower GWP refrigerants in the domestic market of both Vietnam and Thailand. It will also consist of strengthening the local RRC industries by improving its technical capacity in order to design these efficient ACs using inverter technology, and thereby increasing the confidence of the regulatory bodies in the different countries to be able to raise the MEPS without damaging the local manufacturers. and then catalyzing the market shift to more efficient air conditioners with minimized increased costs in order to help pave the way for not only the transition, but specifically also an economically viable market. Next slide, please. Now, who are the key stakeholders? The key stakeholders are, as a first, the locally owned AC manufacturers, both in Thailand and Vietnam. And then, of course, secondly, the government. So in Thailand, it is the National Ozone Unit and the Thai Industrial Standards Institute, which is under the Department of Industrial Works. Then also the Department of Alternatives Energy Development and Efficiency under the Ministry of Energy. In Vietnam, this is the National Ozone Office under the Ministry of Environment and Natural Resources, the Department of Energy Savings and Sustainable Development under the Ministry of Industry and Trade, then the Standards and Quality Institute of Vietnam under the Directorate of Standards, and then the Metrology and Quality under the Ministry of Science and Technology. Next slide, please. Now, the approach under the project and the different components is that the first component really focuses on the strategy support, so the market assessment, the regional workshop, and then to prepare energy efficiency cooling management plans, and then a final regional workshop. And then the second component really focuses on the technical support, specifically for the manufacturers. So that is really the design of the energy efficient inverter AC prototypes, and then a very detailed training so that these local manufacturers really can understand how this inverter technology works, also on a component basis, and maybe even work together to order different parts so that the prices will come down and they're able to then confidently start producing them themselves. And then on that basis to also provide the policy support, desk review of the policy, the review of the MEPS, the labeling schemes, the testing standards, and then field test assessments of the energy performance so that the energy performance can be reliable, and on that basis then give sufficient confidence to increase the standards. Next slide, please. Now, if you look at the scope of the energy efficiency cooling management plan, it also has a number of key elements. One obviously is the state of the refrigerant and the energy efficiency technologies by the different sectors, but presenting in an integrated manner, including specifically the technical potential for more climate-friendly cooling. Then the strategy part, which is basically summarizing the analysis, but also prioritize where to start first. Then to integrate with the existing targets under the HPMP, the phase out, but also the NDCs, in order to really help define the goals and the targets. And on that basis, prepare the action plan and the roadmap. And that should then also include the incentive mechanism. And that includes financing and possible approaches to be able to scale up. Next slide, please. Now, if you look at the technology transfer, that is really at the heart of the program. That will consist of the access to the intellectual property and know-how, specifically for inverter-based product design and how to optimize the performance. Very detailed training and software, so that the companies can really use the software for the design. Then to support the development of the prototypes for the different RRC models. And then also very specifically do the lab performance testings of these prototypes so that it's clear that in the specific climatic conditions in both Vietnam and Thailand, that the prototypes actually work. Next slide, please. Now, again, if for the different components and the deliverable at the timetable, if we look at the strategy development, that is really focusing on the energy efficiency cooling management plan. The proposed completion is November next year, which is slightly delayed from the original date in March. Then the policy development with really the recommendations for the policies in the different countries and the regulatory frameworks, that should also be finalized by November next year. And then the technical capacity development, really that describes the technology and how the know-how and how it can be transferred, should be finished slightly before in October next year. Next slide, please. The funding, the total funding that was approved by K-CEP is channeled through the World Bank under 3 agreements. This is maybe a little bit detailed for the conference for today, but there was one strategy development that was signed in 2018, and then there is the second and the third for the technical capacity development and the policy development, which should be countersigned pretty soon. Now, if we look at the country participation, we obtained endorsement both from the Ministry of Environment and Natural Resources and the Ministry of Industry and Trade in Vietnam, as well as the DIW and Ministry of Environment in Thailand, and they were secured in March. Now, if the technology transfer is successful, then the governments will adopt a plan that really commits to using a lower GWP potential for refrigerants, and also increase the MEPS by 20%. Also in Vietnam, well, we had the meeting together there half a year ago, and they have quite a regular update of the MEPS anyway. So it is, but as in many countries, the government is really looking for the analytical basis to justify the potential for the increase. The increase of the MEPS by 20% from the 2020 target, that's also agreed by Asia and Shine, and that would be really good outcome. In the different countries, there are 11 AC manufacturers in Thailand and 2 in Vietnam, and they all have committed to the project as of February 2019. Yeah, and as we also discussed earlier, one of the manufacturers in Vietnam was hesitant, but then indeed when we followed up, it is clear that they are phasing out from the market. So that's why it was also logical that they dropped out. Now, originally we also had included the Philippines, and 2 AC manufacturers also committed to the project, as well as the Department of Environment, the DNR. And the Montreal Protocol focal point, but they disagreed on the choice of the technology, and therefore the Philippines withdrew from the project. And as a result, we are looking for the potential for another country in Southeast Asia to join instead of the Philippines. Next slide. Just a bit of overview of some of the key activities under the strategy development. There was the consultation and knowledge sharing workshop, the kickoff workshop that was held in Bangkok last year. There were quite a range of experts, government officials and AC manufacturers who joined from the Philippines, Thailand and Vietnam. And the workshop already identified the challenges and options to accelerate energy efficiency improvements, but at the same time integrating lower GWP refrigerants, and shared also information on the options. And based on this, indeed, both the government and the industry support was obtained for the activities, and also the input for the specific terms of reference on the technology transfer. Now, for the energy efficiency cooling management plans, the terms of reference to support the national cooling plan has been developed and agreed by both Thailand and Vietnam. For Thailand, the terms of reference has been expanded to also cover some enabling work on the HFC phase out for reasons of efficiencies. And we are at the moment actually busy with the consultant selection that is currently ongoing through our system. Now, then also the rapid AC market assessment was completed. And I think there are a lot of the results have just been presented on that. Next slide, please. Then for the technical capacity development, also there, the terms of reference for the support to the manufacturers have been finalized. It also has been endorsed by the participating countries. And that also means that the triggers for receiving the funding has been met. There was the launch workshop, the terms of reference and the commitment letters from the industry and the government has been obtained. And at the moment, the consultant selection process will start in the third quarter of 2019, which basically means after the summer holidays. And obviously, as soon as also the EFO is signed by K-CEP, then the technical assistance activity for the technical capacity development will take about 6 months for completion once the consultant is in place. Now, and then for the last component on the policy development, there will be the analysis of the field test on the energy performance of the inverter room ACs for the different applications. But this will be done in parallel to the technical support activity, because it's also a crucial element for the countries to really determine what are suitable and possible MEPS levels for the region. And then as the last component, the review of the MEPS and the labeling schemes for the high energy efficiency RRCs. This work has been integrated in the terms of reference, and obviously it will also already build on the work that is already conducted by CLASP. It could even be that there may be multiple revisions, because we know, at least in Vietnam, the ministry is already looking at increasing the MEPS. So we could also foresee that rather than pushing for one single revision, there can be an earlier revision on the work that was already done by CLASP. But then once the technology transfer has been done and is further accepted and further analysis has been done, that further increases can also be done. Next slide, please. I think this is maybe a little bit too detailed, so I would propose to go to the next slide.
Looks like that's it.
Yes, and that's it. So we are just a little on time, too late for the Q&A.
Yeah,
yes.
We're running a bit behind, but thank you for your presentation, Caitlin. And we still have a few minutes left for Q&A, and we've already received some questions. So we're going to dive right in with the first question. And if you have any others, please send them to us. We can endeavor to answer any questions we don't get to live via email to all of the participants later. So the first question we wanted to address, we received from Luis Lopez, which was, have you considered checking price versus efficiency in these market studies? So yes, we do look at price versus efficiency. This is actually a critical component of our analysis. What we do with the data we get from retailers through all of these retail surveys is we develop a linear regression where we look at the relationship between price, cooling capacity, and efficiency level. Based off of this linear regression, we then control for the cooling capacity. So we look at the most popular AC sizes in the market, and controlling for that size, we develop a cost efficiency curve that relates cost to efficiency. Using this cost efficiency curve, we actually input all of this into our policy analysis modeling system, which you can read more about on our website or in the reports. And we use this to develop our scenarios. So all of our scenarios are very based on this relationship between cost and efficiency. And if you'd like to explore our methodology more in depth, I would point you to the reports that we have published on the website.
Yeah, and I think it's an important question because, of course, any increase in efficiency will have an impact on price, and it can have an impact on consumers. That's something that we'll look into these scenarios, because the idea is that the MEPS will bring energy savings, environmental benefits, but would not adversely affect consumers. And of course, this is an important part of the equation. So by looking in more detail at the reports, you will be able to see that the different scenarios that we model have information on what that means for the consumers in terms of the total life cycle cost. And I think in general, the higher cost of the high efficient appliances, it's compensated by longer savings in the utility bill. And if you want more details for any of the countries, all that information is already included in the reports. So thank you for that question.
Yes, so we have another question that I'd like to pose. And maybe maybe Naomi in Kenya or Lena could take a stab at answering this. But the question is, the case of Thailand and Vietnam shows that moving from EER to SEER or CSPF could lead to greater market transformation towards higher efficiency inverter ACs. Could this be an option for Kenya or the rest of Africa, or maybe for the Philippines?
I'll go first. because I'm the farthest away from you guys. So this is something that has been considered in Kenya, that was even considered when they were revising the MEPS. But because it's a newly regulated market, they wanted to go with something a bit easier, a bit more familiar. So this will be considered in the next revision. That has been the communication from the regulator and the Bureau of Standards here. And of course, we all agree with the statement that it will lead to more transformation and also give inverter ACs an advantage in the market.
In the Philippines, as I mentioned, that DOE is currently in the process of adopting a new MEPS for air conditioners that will have a metric measured in CSPF. So with this new policy, they will be moving to a new metric. Previously, under current policy, they do measure in EER. One of the fact is that only fixed speed ACs are subject to current regulation, while under this new regulation, both fixed speed ACs as well as inverter type ACs will be subject to the regulation, to new MEPS, and then the metric that will be used will be in a CSPF.
And I think in general, not only for Kenya and for Philippines, but for other markets, a transition to a seasonal performance metric has proven an acceleration to high efficiency equipment. So maybe Colin, you wrote a paper about this. I don't know if you have any comments on those case studies.
So I think as we sort of saw in the Thailand case, the key thing is not just to move to a seasonal metric, but to move to a seasonal metric with the same requirements applied to all air conditioners. As we saw with the Thailand case, maintaining separate requirements for inverter versus fixed speed units slows the process of market transformation. And so it is important to make sure that you use the same requirements for both types of air conditioners. And if you're interested, I can point you to a paper from ECEEE that I wrote on comparing the different experiences of moving to a single metric and how to do that, which standards to use, test procedures, and so forth.
Great, thank you for that. Should we take a few more questions?
Let's take a couple, and then.
Yeah, okay. It's 10:30, but we're going to take a few more questions while we're still live, and then we'll send out some answers later on. So another question that we received is for Naomi, which is, did the new MEPS in Kenya have an impact on the prices of the products? And if so, how did the prices react? Have you seen anything yet as a result of the new MEPS, or is it still too early, Naomi?
Yeah, so thanks, Rebecca. So yes, it's too early. So implementation, as I mentioned during my presentation, implementation of the MEPS just started in May, actually, because the standards were published in April. And so we haven't yet seen the data on what the prices are compared to the data that we had collected before. And in the report, we give a bit of analysis on the prices that we found. The price data was not very good because the price depends on, because it's a small import market, for example, whether you bring in a large consignment or a small consignment, so the prices differ. And we didn't find very clear correlations between price and cooling capacity, price and any other factors. But yeah, once the MEPS have been in place for maybe a few more months or maybe a year or 2 years, then we can start hopefully to see some correlation between those two things.
Great, thank you, Naomi. So I also have a question here for Caitlin. The technology transfer piece of the World Bank's program, where the 10 to 12 manufacturers have signed up, is this purely focused on technology that drives efficiency, or also technology that can help bring down the cost for those technologies, such as various components?
Is of course a major aspect of it. So as part of the training and the prototypes, there will be a lot of attention focusing on the different components that are needed, because we do think that a lot of the components are excessively expensive. So we also hope by offering this training together to different manufacturers jointly, that there can be further synergies that can be explored by different manufacturers pooling together and maybe even order key components together in order to drive down the prices. Now, this is not objectively the first objective, because the objective is firstly focused on the technology itself, but definitely it's one of the side objectives.
So we have an interesting question, and I want to put it to our panelists and see who's interested in answering it. So one of our attendees has asked what we think the role of cities is in fostering energy efficiency in ACs in those countries, and if there are any programs or outlooks for cities to contribute to improving energy efficiency. So Colin.
So I think in Thailand, you have this situation, as I mentioned, where highly efficient, especially highly efficient large capacity units are extremely cost effective. And so I think cities could take the lead in requiring higher efficiency even than the EGAT number 5 label itself, and start pushing the market by procuring such units for their city government buildings and various facilities. Local government often controls, say, police stations, hospitals, schools, and so forth. And so making sure that they're buying the highest efficiency units, which in this case are quite cost effective, is a good way of taking leadership in moving the market to higher efficiency.
Thank you, Colin. Is there anyone else who has any insights they'd like to add?
Maybe a thought on market transformation activities and the role of cities, maybe by partnering with real estate developers. We know that in some of these growing cities in Southeast Asia, there are a lot of high rises, and of course the equipment already comes installed. So there's a choice to be made on whether you install low efficiency or high efficiency equipment. And I think there's an opportunity there to work with the real estate developers to provide some incentives on choosing high efficient equipment, and the cities could play a role.
Thank you, Anna. So let's try and take one more question. So I think this one is for Caitlin. So one of our attendees wanted to know if there's a reason why the World Bank is working primarily with the environment ministries in Thailand and Vietnam, and whether or not you've also involved the energy ministries.
No, it is very much between the Ministry of Environment, but also the Ministry of Industry and Trade. But it is also the case that since it is folded under the overall objective to produce the overall cooling plan, and that is legally the mandate of the Ministry of Environment. So for that reason, it is the Ministry of Environment that has the overall coordination capacity. Also because in parallel to these activities, we support the Ministry of Environment in the HCFC phase-out, which is specifically under the ozone unit under the Ministry of Environment. But coordination with all the key ministries is very much part of the project.
Thank you, Caitlin. So it's about 10:35, so we're going to wrap up, and we want to thank all of you for joining us today. And for those questions that we were not able to get to live, we'll try to send out answers later. Additionally, all of these reports that we discussed today are available on our website at clasp.ngo, so please explore them at your leisure and enjoy the rest of your days. Thank you.